Hello everybody, hope you are all well. It's Joe here again, and I've been asked to make a follow-up tutorial continuing our work with FreeCAD. If you haven't watched it already and you're interested, we did a getting started with FreeCAD video last time, so if you look on the Ffiws channel you will find that and you can go through that. And we're going to build on that today, and we're going to explore some other ways to create objects and extend our knowledge of the sketching tools in FreeCAD. What we're aiming to do, so I'm quite proud of this, in this month's Hackspace magazine, who some of you might know that I write for, I was asked to write a tutorial about building up a robot. So I've designed and built this robot, apart from the bottom bit where the wheels are and the metal chassis. That's an off-the-shelf kit available for about 20 quid off eBay. But the rest of it I've designed and built myself. So all the red stuff is stuff that I've designed in FreeCAD and 3D printed, and then I've added some electronics which I'm not going to particularly talk about today to control it. So the cool thing about, the thing I think is cool about this robot is that everything is modular. You can see that it has all these little racks of holes in various points across the front here, and you can see that bits like these little LED headlamps have been attached to these hole points, and these holes are all on 10mm between each hole in like a grid wherever they appear. So that means that it's kind of modular. It's quite easy to make extra parts for it. So today we're going to make an extra part for this robot, which is going to be a little bit similar to this right angle bracket, but it's going to be a bracket that's designed to take a Raspberry Pi Zero computer, which, don't worry if you don't know what that is, but it's a little electronics doohickey that I want to add to this robot. Oh, this robot is all open source, so if you find the free download of Hackspace Magazine's article for this month, which is issue 32, I believe, you can download it, and the links are there to get all these files if you wanted to explore or look at what I've done, or even build one yourself. So we're going to open up FreeCAD, and we're going to take a slightly different approach than the last video. But some of it will look familiar. So first of all, I'm just going to show you, because I've actually made this object before, and I'm going to show you the object just so that you see what we're aiming for. So this is the object. As you can see, it's a this main rectangle here is exactly the size of a Raspberry Pi Zero computer, and these four holes are the same size mount holes as the little Raspberry Pi Zero computer has, and so it should mount up to there with some nuts and bolts pretty precisely. And then the only other bit is it has this tab which has three of these mount holes which are the same size and at the same spacing as the mount holes on the modular robot. You can see that when I've opened this file, it's opened in the part design workbench as opposed to the part workbench, which we used in the last tutorial primarily. There's a few reasons that I've done that. So what I'm going to do now is I'm going to close this, and I'm going to create a new project, and we're going to start again. But if your version of FreeCAD hasn't opened you up onto the part design workbench, go there now. Okay, so the first thing that you'll see is the part design workbench offers you as a starting point this start part, which is hard to say, and it has this create body option, which we are going to click in a second. So in part design, everything you design should be part of a body. You can have more than one body in a project, but a body is an object which is a single continuous solid object. So that means it's not like an assembly where you might have two or three different objects. In a single body, there would be one object, and it would be continuous. It wouldn't be like a blob of something with a totally separate blob of something else, because that wouldn't be continuous then. A way to think about it that's quite easy is if you imagine a nut and a bolt. If you have the nut and the bolt separate in your hands, then they're two separate bodies. So if you wanted to model them, that's how you would model them. if you put them together, they're still two separate bodies, but they create a fastening assembly. So they're still actually separate items, it's just that their mechanisms join together. So yeah, so we're going to create a body. The other thing of note about a body, and this might become more obvious as we go along, is that a body automatically fuses together any objects that are touching within it. So in the last video, when we drew we used the primitive tools on the part design workbench to create like a cube and a cylinder, and then we selected them both when they were touching, and we then clicked another tool to create a union to make those two items one item. In a body, we don't have to do that. Everything that's added that touches the body becomes part of the continuous solid. Okay, so we're going to click create body, and then the start point looks familiar to some of the stuff we did in the last video. We're going to create a sketch. Okay, it asks us again, but in a slightly different way, which sort of plane we want to create the sketch in. So again, we're going to click this top one, the XY plane, and we'll click OK. Just before we OK it, just to explain again, this XY plane now, if for example you were looking at a 3D printer in the Ffiws makerspace and you were looking down from above onto the bed that gets hot and moves and builds up, the model is built onto, if you're looking down at that bed is the XY plane. So that's just an easy way of thinking about where we're looking from. So we'll OK that. And then it jumps us to the Sketcher workbench, which should look familiar from the last video. So we're going to start our sketch in a second, but I've actually downloaded a little plan from online of a Raspberry Pi Zero, because just to remind me of the dimensions that we're aiming for. So basically we're going to make that first big rectangle. So we need a rectangle that's 65 millimeters long and is 30 millimeters high. So to do that, we're going to use the create rectangle tool, and we're going to draw our rough rectangle again, and like last time we've got these 4 degrees of freedom, so we need to constrain it somehow. Okay, so a couple of different things that we didn't do last time. We're going to start to use this constraint here a lot more, which is where you create a symmetry between 2 points with respect to another line or a third point. It's a really, really useful way of constraining a sketch. So what I'm going to do is I'm going to select that point there, I'm going to select that midline there, and I'm going to select this point here, and I'm going to click that constraint button. Now you can see what it did was it made the distance between this point and that line and this point and that line equal, and it is now constrained to always be equal, so it will always maintain symmetry around that point. I'm going to do the same with that point, that line, and this point here. So now, with it adds these 2 little red triangles, this now creates a symmetry there. So now all I've got to do is create some distances between one of these points and this line, and one of this point, say, and this line, and that will create all the constraints that we need for this rectangle. So our rectangle needed to be 65 millimeters across from this line to this line. So we're going to put a horizontal thing, but I've marked this point and the center point, and I'm going to create a horizontal thing there. So obviously this needs to be half of that value. Now, if you are clever, you can work out 65 divided by 2, but here's a top tip. You can also, in FreeCAD and lots of other CAD environments actually, and in Inkscape for example, if you put in 65 divided by 2, it will do that for you and work it out to 32.5. Not too difficult to work out half of 65, but if it's a more complex measurement, then it's worth knowing that little tool. Okay, I've forgotten how tall. No, I haven't. It was 30 centimeters tall. So we'll click that line and that one, and we'll put a vertical point of 15, obviously half of 30. Okay. So there we go. We've got the outside without the sort of radiused edge. Actually, we could add those radial corners at this point. This tool here is create a fillet between two lines or at a coincident point, and you can click a point and it will add a fillet, and then you have to constrain the radius and sort your lengths out again. So actually I tend to do fillets at the end when we've got the object back in the part design by actually clicking the lines on the edges and using the fillet tool. So we'll do it that way, but that's just to know that that's there. Okay, what else do we need on our plan? Well, we need these 4 holes here. Okay, so to do these 4 holes, we are going to draw some circles. So what we're going to do is we're going to draw a circle, and we're going to roughly put it in the right position. Interestingly, in the Sketcher tool, if you're in the right quadrant of so if you think of these 2 lines intersecting, and this is 0 and this is sort of coming out positive. If it was a graph, it would be counting up this way in numbers and counting down negatively this way. FreeCAD isn't too worried about whether numbers are positive or negative in the quadrants. It just imagines. So say you set a distance between this line and this point here. It doesn't need you to put in minus 27.24 or whatever. It just presumes that that's what it is because of where it is on the page. Anyway, don't worry about that too much. What we're going to do is we're going to set the diameter of this hole to the diameter of the hole that is on the plan, which was, I believe, 2.75 millimeters. Yeah, 2.75 millimeters. But this is written as a diameter, so again we can use our divide by 2 to set the radius, because you set the radius with this tool. So we're going to click this tool and it asks for the radius, so we're going to say 2.75 millimeters divided by 2, or 3.125, 1.375 even. There we go. So that's sort of the right size. What I'm going to try and do is select this object and copy it, and missed. I'm going to do a Control-C, Control-V, and then click. So I'm just copying this item by selecting it, left-clicking, doing a Control-C, which copies it, and then moving out to the other quadrants where I want them, and then clicking again, and it drops another version of the same size circle. So click it out to here, do a Control-V, there we go. So there we go, we've got 4 circles that will eventually become holes in the right sort of quarters of the rectangle. So now we need to set the central points to be in the correct locations for the holes. So what we're going to do is just zoom in a little bit. I'm actually going to use the same idea. So I've selected the centre of that circle, this middle line, and then I'm going to move across and I'm going to select this centre of that circle, and I'm going to select a symmetry between those. So again, those are going to be symmetric around this central line. I'm going to do the same on these circles, select those, and then I'm going to do a really bad zoom and lose my work. So there we go, just use the zoom tool to bring that back in. Gosh, zooming is a pain on this laptop, it has to be said. Oh dear, it's hard because it's so small. There we go, that's better. So where were we? I selected that one. That one's got a yep, that one's got one there. So I'm going to do a symmetry between this and this. There we go. Oh, I obviously selected too many things. 1 point, one line. Oh, there we go. Okay. Now I'm just going to have a quick look at the plan. So again, we see that the hole centres from the centre line of the board are 29 millimetres, and they are all 23 millimetres between the centres of these two holes. Okay, so if we select this and select the vertical height there, we can do it as 23 divided by 2. And then if we zoom out slightly and select the centre of that one and the centre of that one, and select the select the distance between this and this as 20. No, what was it? I've forgotten. I've closed the plan. Was it 53? I can't remember. Let me just find that. Plan again. They were 58. There we go. My memory is useless. 58 millimetres. So put that at 58. Okay, there we go. So it's all gone nice and green. Everything's in the right place. If we wanted to tidy it up a little bit, we could move some of these constraints out of the way so we can see what things are applying to what. If we close that now, we have a fully constrained sketch in the preview window. So yeah, we've got some tools, the things that we can do with that sketch, and similar to the last video, we're going to use the pad tool, but 10 millimeters a bit thick. I've been making these brackets 4 millimeters thick. So there we go. So we have our rectangle. Now, of course, we want to add that other part that we're sticking off with the mount holes. So what we're going to do is we're going to create another sketch, but we're going to map it to a face of this object. So what I'm just going to do is make sure that I'm on the top view here. So we're looking down again as if this was the bed of the 3D printer, and I'm going to select the top face of this object, and I'm going to click the sketch button again to add a new sketch. Okay, so now we're back in the sketcher, but we can't change any of the original sketch in this because this is like an additional sketch, but we can add another sketch and pad to it, and it will be joined to the original article. So what we're going to do is we're going to draw a rectangle roughly in the right place for where we want it, and we're going to do some very similar things again. So it's good practice. We select that point, that line, this point, make a symmetry. We're not going to make a symmetry this way because we want it to be off center and to be hanging off the bottom of this part. So I think we want this dimension to be, I've missed that. We want this dimension to be, I think I have this at 25 millimeters or 30 millimeters, 25 millimeters. Can't remember. That looks about right. Yes, so that's pretty much the object that we need. We've got 2 degrees of freedom. So one is that it doesn't know where it's sort of anchored, what position it's in, and one is the width of the item here. So if we create a horizontal constraint between that point, don't miss the point, between that point and that line, and we make that 15 because I think we want this to be 30 millimeters. And then if we get that point and this line and make that, give that a vertical distance between it of 0, then it basically just ties the top of this object to that line. And that's a fully constrained sketch. Okay, if we close that again, we're going to pad this sketch. Now, I can select this pad and I'm going to click the pad tool up here. Again, it automatically sets it at 10 millimeters. Actually, I'm going to change how we do this. So we could have made this by padding it and then go. What I was going to do was map another sketch of this face and put 3 circles on to go into. No, I will do that. I will do that because then I get to show you another tool. That's what I was planning to do. Okay, so let's turn that to. Sorry about that. Let's make that 4 millimeters again. And actually, I don't think it's quite sticking down off this piece enough as the last one, as the one that I made previously. So let's just OK that for now, but then let's go back in and edit this sketch. So what we're going to do is find that this constraint, and we're going to change it to make that a distance of 5 millimeters. That looks better to me. Close it, and then you see that we've moved it down. Okay, so we're getting there. We've got our big rectangle, and we've got our small rectangle that's been padded. That's going to be the kind of mounting bracket. And again, we haven't had to select these objects and combine them together. They just automatically are together. Okay, let's make the holes and then let's put the nice fillets on to make the corners nice. So to make the holes, we want to put the holes into this part of the body. So again, we're going to make a new sketch that's attached to that part. Okay, and I'm going to show you, so there's a few little ways that you can make holes from sketches. The way that I'm going to do it is to use a hole tool, and the hole tool actually it just needs to know that there's a circle in the sketch that it wants to turn into a hole. It doesn't actually need for the circle to be the right size, but I am going to make it the right size just so that I can show you an alternate way that it would work. So I'm going to draw a circle, and then I'm going to constrain the radius of the circle. And I've been making these holes on the robot 2.1 millimeters diameter. That's basically so they'll take a 4 millimeter bolt through them with a little bit of clearance. Okay, so I've made a circle. If we just zoom in a little there, so I've made a circle. And it's sort of roughly in the right position. Now I want to make 2 more circles that are the same, so I could copy and paste and then I could painstakingly line them up and do stuff, but another way to make a sort of series of circles or a series of objects, you can do this with any sketch object, is to select the object and then click this button here, which is create a rectangular array pattern of the geometry. So basically, it creates a tiled pattern of the object that you selected. So we're going to make 3 holes, which this is set to already, including the original. So we're going to make 3 vertical columns of rows of circles in 1 row. So we'll OK that, and then what we've got is this little icon that we can drag out, and we can, when we click, it will create the holes based on where we've clicked. Now obviously we want these in a line, so somewhere in amongst your creation there is an angular constraint. So if you double click on that and change the angle to 0, it puts them in a straight line. Similarly here, there's a constraint that it's created that's the gap between the center points of the hole. So I know that on our robot we made all these holes 10 millimeters. Okay, the next bit is, and I usually drag it to roughly the right place, is I kind of want to place these holes now exactly on this sort of 10 millimeter grid line, so 10 millimeters up from the edge, but also with the center point on this line. So if we click the centre point of that circle and click that line, click a horizontal length and set that to 0. Actually, I don't want this 10 centimetres up, 10 millimetres up. I want it 5 millimetres up. That's how it will match this. So actually, I've got a little bit of working out there to do, because I need to set the reference off something that exists in this sketch. So I'm probably going to set it off this line here. So what I can do is count the blocks. So that's count these grid lines. So 10 millimetres, 20 millimetres, 30 millimetres brings me to here. So if I come down to 25 millimetres, then that should put me exactly 5 millimetres from the edge of that object. So click this, zoom out a little bit, click that, click the height object, set that to 25. There we go, it's fully constrained. We can tell that because the sketch underneath all the constraints has gone green and it's in the right place. Okay, so now if we select that sketch, there is a new tool that I want to show you, which is this one, create a hole within the selected sketch. Actually, before I show you that, I'm going to show you this. This is not particularly for this, but you can also do this if you wanted to create a pocket which doesn't necessarily go all the way through the sketch. You could click that tool, and it's done it to a length of 5 millimeters, which is all the way through. But if I change it to 2 millimeters, you can see that you can create a pocket into your item, and of course you can change the depth of that. Be aware that if you wanted to create a hole and you left it at 7 millimeters, if you went on and added some other object on this side, it would actually cut into that object as well. So sometimes it's worth thinking about, making sure that you're getting your dimensions correctly, because sometimes in a complex design you can't work out why something's got a hole in it. Okay, the hole tool is slightly different. So we're going to click the hole tool, and you can see, oh, it's made some holes, but they're massive. They're like 6 millimeters. So the reason for that is that the hole tool, it doesn't actually worry about what size your original circle is, and it allows you to change all the geometry in this dialog box that pops up. So we're going to put them at 4.42, that's far too big, 4.2, which is the size that we want, and I'm going to set the dimension to 4 millimeters, which doesn't quite go through all this hole. So this is quite interesting. You can see there that it's created like a weird pointy bottomed hole. Well, that's because quite often in CAD you want to design something that's going to be drilled by a CNC machine, for example, and so it defaults to the angle of a common drill end. Because if you imagine like a drill in a handheld drill, if you drill but you don't go all the way through, it leaves the pointy end of the drill in. So we're going to change that to flat, and then of course for 4 millimeters clears all the way through there. Okay, so we've pretty much made our part. We're going to OK that. We're going to get it to a more sensible size, which is really hard on this laptop and drives me a bit potty. Okay, the only thing we need to do now to make it like the other one is we want to select these edges by clicking these edge points, and this is to make our fillets like we did the other week. Click the edge points and click the fillet tool, which is this one here, and funnily enough, I've used 3 millimeter radius fillets on all of this robot thing, and actually the Pi Zero computer that we're designing for has 3 millimeter radius edges as well. So that was a happy coincidence that makes it look very well designed when it's just a bit of luck, really. Oh, I've missed one there. Let's just stop that. Let's just put a radius on these. Okay, create a fillet. Change that to 3, and we're done. Okay, there's our piece. So, a couple of things. One is when we when I showed you the other piece, it was different colour, and somebody asked me on Twitter the other day, how do you change the colour of objects? Well, if you right click over the selected object, there's an appearance tab. You can, sorry, I clicked that a bit quickly. You can click the shape colour, and you can change the colour of the object, and also you can do things like change the transparency of the lines and parts. That's useful for if you want to be able to, if you've got a complex object and you need to be able to see what's going on inside an object, that can be a very, very useful thing. Okay, so there we go. We've made our part as a body in part design. Last little bit on this. Something that people get weirded out with bodies is they can't double click them and select them and move them. And that is true. So, and also people sometimes want to copy a body and create another. Well, actually, it can get very complicated because if you think about it, this body is made up of all these reference points and all these operations that are all sort of related to each other. So one little tip is that if you wanted to say print 2 or 3 of these, or you were making an assembly and you needed to have 2 or 3 and you need to move them about, a way to do that is to select the body or select the last, the highlight, the geometry of the body, and go in the part design thing, and you can find somewhere is create a am I in the wrong bit? It's not created. Where am I looking? I'm looking because I don't do this often. Actually, sorry, you have to change to the part workbench, and there you go into part, and you can create a simple copy. There we go. So now you have this simple copy that if you, in the part workbench, double click that object, you'll remember from the other tutorial that you can then move this object and rotate it using this set of tools which we covered in the previous video. So that's if you wanted to create multiple instances of that body. It's a simple way of doing that. Okay, we're going to kind of leave that there, apart from we're going to select this and we're going to move over to the mesh design workbench, and then we're going to do a file and we're going to export an STL of it. So we'll call it the RPi0, hit the caps key there, bracket, and we'll save it on my very messy desktop. It'll save it as an STL. Let's click save, and then if we go out of there and open up, so this is Prusa Slicer, which is one of the slicing tools we use in the Ffiws makerspace to slice objects to make them ready to be 3D printed. So all I've done is I've in the Ffiws makerspace, these would all be set up for you, and you would just go in, click import an STL, find the file that we just created, which is there, RPi0 bracket, and there we go. There's our object sat on the imaginary 3D printer. It needs some support because when we try to print this higher object part of the object, it may sort of flop over before the plastic cools. So what we'd do is we'd set the support setting to everywhere, and then, and this is just a quick overview. Click slice now, and you can see that it's sort of created all the slice patterns for how it's going to print that object, and added the support materials. Click export G-code, save that to your SD card in the Ffiws makerspace, and put it in the machine and click print. Couldn't be simpler. We'll leave it there for now. Thank you very much for watching, and take care, and hope to see you soon.